functional programming. We're not going to be going into any, obviously, frameworks or anything else. We're going to keep it to core concepts. Everything's going to be super simple as much as possible, because trust me, when we get down a little bit further into the techniques and the different things that are going on here, even the most seasoned senior developers will actually get confused with some of these concepts. So even if you go away with like a 50% understanding from this workshop, I suppose what you'll have learned is a lot more than a lot of senior engineers will ever grasp. So it's definitely worth learning, because especially now, with a lot of frameworks are actually pushing this functional style of programming into the way they define how you do things, because it makes it easier to test and everything else. So you often get test these functional skills when you go to interview. So often these things, like I suppose the most number one failed answer I see in interviews is the closures question. So hopefully if there's anything you learn from this, it's closures. So let's jump in. So I just throwing up a quick slide myself in case anyone wants to connect with me. If anyone follows me on LinkedIn or anything already, you'll know I'm very active on there, but I'm trying to do the other stuff as well now, which isn't so good. So yeah, if you want to jump onto any of those and connect with me and ask questions afterwards, that's probably the place to do it. So this is what we're going to go through today. I had put up in this in the meetup that we'd go over partial applications and currying, but there's just not going to be enough time, because I suppose even with what's here, I could talk for about 3 hours. So rather than like half-ass some of the concepts, I'm going to jump in and try give a good understanding to the concepts that we can cover. There's going to be some like time, like before each time we jump into something, I'm going to give you some code samples you can jump in and actually test out and have a look at to see if you can actually figure out what's going on, and then we can talk about some of the actual terms and things like that actually that we'll be talking about. Because like usually you'll hear like a really scientific term like functors and things like that will just throw you. You're like, I'm never going to understand this. But that's what we're going to try and get rid of today. So this is probably the best meme for this. This is most functional programming tutorials on the web. We start with a function, and now you have functional programming all of a sudden. Yeah, I'm sure we've all kind of seen that and just kind of walked away as a result. So the real question, I suppose, before we start and jump into the concepts is, why functional programming? Does anyone actually use functional programming in their job, I suppose? As like, is that the style of programming you're told to program in all day, every day? Yeah? 1, 2, cool. And does anyone have no programming language like Haskell? No? Here. No bit. Yeah. Cool. So JavaScript is a language that lets us kind of mix paradigms. So we'll have object-oriented programming and we'll have functional programming, are kind of the two paradigms or styles of programming you'll see with JavaScript. Why functional programming? So I got into functional programming by accident, really, because I didn't realize I was doing functional programming. So I didn't realize I was doing functional programming by actually trying to compartmentalize my functionality of all my functions to make things easier to test and I suppose easier to debug, and then just generally reuse things, keeping your code base dry. So this kind of goes back of, we want to make sure that humans can understand the code more than computers. So you get a lot of people when they start engineering and early days in engineering where you're trying to prove that you're smart rather than prove, I suppose, as a concept I always say to people that sounds really depressing is, code for your replacement, and that doesn't have to be a negative thing. It can be, you do not want to be called after a month, after leaving your last job saying, hey, we have this piece of code that we can't figure out what happened. So by making readable code, it means you can actually leave comfortably and not worry about things that are going to like blow up behind you when you leave. Now, some people would prefer the other, to engineer themselves into a job, but if we're collaborative coding environments and things like that, we want to make things simple so everyone else feels inclusive. So what we're going to do is we're going to try and break things into small, simple functions we're going to try and contain the consequences into the small functions. So again, functional programming, we could have guessed it's we're going to use lots of functions. And we're going to combine and recompose the functions to keep everything dry. So we're not going to repeat the code. And that's the whole point in this. We want to get as much line reuse as possible as well. So if we can keep the small functions, like maybe one line codes, and with arrow functions and things like that, now you can actually, execute a function all on a single line. That lets us be really functional. And I suppose things like that have slipped into the language recently to actually allow better functional programming. And we're going to cover off some of the methods that have been introduced recently that are actually just showing that the language is trying to adopt this functional approach. So I'm going to give everyone a second to get this. This is the link to all of the stuff I'm going to be going over. And basically there's little exercises, and I have a little extra sample in the end. So I'll give everyone a couple of minutes to grab this. All right, higher order functions. That's what we're going to start on. So does anyone know what a higher order function is? What is the definition? Calls another function? Is that all it does? It returns a function? Does it return a function or does it call a function? Go on. It doesn't have to do both, but it can do either or. So a higher order function is simply just a function that takes a function as a parameter or returns a function. So we hear these fancy words and they sound very scary. It's not that complicated. You've probably seen it and used it lots of times before. And we can actually jump in. Yes, so a function that receives or passes out a function, okay? So if we jump into the REPL there for a second, going to go into the intro. So basically, I'm not sure how to execute the stuff in particular files here. I think you have to import them and everything else. I'm just going to copy and paste things into the index and run them from there. So just to kind of go over some of this very, very simple kind of functional stuff before we get into the into everything else. So the whole point is we want to stop duplicated functionality, or stop making things super specific, and stop bugs. Okay. So if you take the intro.js there, we have a lovely function called copy, array, and double. So this is a good functional name because you can guess what it does. So we copy an array and we double. I suppose we double the parameters, is probably even better name. But so when we do that, what happens when we, I suppose, want to do something like add 2 to an array element instead? So what if we want to copy array and add 2? Then all of a sudden, this function, although it has 95% of the right logic, we tend to have to stop, and we'll have to create a whole new function again just to actually get it to work for us. So when we get into functional programming, we're going to use higher order components a lot. And here's our first sample of that, where we have copy, array, and manipulate. Okay, that's a lot more of a passive naming convention. So rather than dictating the one thing it can do, we're going to say this function copies an array, and then we pass it a manipulation function. So all of a sudden, if we wanted to multiply by 2, or we wanted to add 2, we can just pass 2 different pieces of functionality to that. So if we have a look at the copy, array, and manipulate, we can send it a function, and you don't even really need to look at what the function does. You can read it here. Copy array, we take a test array, and we double the number. So that functionality is pretty easy to read. You don't need to go over each line of code to infer what happens. And that's the difference between declarative coding and imperative. Okay, when you're declaring the action, or literally able to read it and understand it by reading it, the declarative way of programming. And you're going to hear that term come up a lot when you're talking about functional programming, and that's declarative. Okay, any questions on this? Cool. Okay, so just to go quick through it, like the double number, it has a single line basically of code. So we know if double number breaks, it's going to be very easy to find out where it's broken. That's going to be a pretty easy thing to fix. There's very, few points of failure when we start doing these things, because this is the only manipulation here. The copy array is taking a new array and returning a new array. So, we're stopping side effects here as well. So, map, filter, and reduce are some of the methods given to us by JavaScript to functional programming natively. And now that you know what a higher order function is, you can guess what kind of functions these are, because we usually give it an array to operate on, and then we pass a function for it to operate on the element. So in the array methods.js section, I'm going to give everyone a few minutes to go through this. And basically, just so we understand, because a lot of people kind of mix up, I think, arrow functions and feel like they execute straight away when they start seeing them. They just assume that they just run. So this is a small exercise of just taking the anonymous functions and pulling them out into separate functions. Okay? So it's just to make sure that we can see how separated these things are. Because in this code, it's not done in a very functional way, because we can't actually test the functions that we passed. So we're going to make it a little bit more functional by pulling it out. So I'll give everyone a few minutes to actually pull out those functions. So say in the half numbers, we'll take this bit of functionality into its own function and try recompose these functions to include that. That make sense? No? Okay. Yeah. So let's, up here, I will go const some function equals something. Okay. So if we are taking the half values takes this callback here, takes an x parameter, and it returns x divided by 2. So it's a lot more declarative when I do it this way. See, that's what I mean. It is a little bit confusing when you read it that way, that these are actually pieces of functionality that we can pull out. Okay? I'm going to take this off because you definitely won't cheat. So have a play around and see if we can get each of those. You can ignore the bonus at the end. I'm just going to talk through that after, because it's just going to show you, I suppose, one of the most powerful concepts in functional programming. But if you master these, it'll be very good. And after this, I'm going to actually jump in and we'll talk about what each of these functions do and when to use them versus the other ones. But first off, I just want you to extract the functionality first. So the real thing to notice, I suppose, when we're going into this is we don't actually call the function. Okay? That makes sense? We don't call the function. Yeah? Yeah, so this is where people usually get confused here. So they see a function and they assume when it's an anonymous function because they see them passed around and where functionality is usually called. When really what is happening with these map, filter, and reduce functions is they're actually calling the function for you. So again, it's a higher order function where it actually calls the function inside the body of that function itself. So that's why we wouldn't do something like this, because then we would have executed it already and it would have no value, so therefore it would make no sense. So when we go into the map function, it passes the value of each element in the array and calls it each time. So we're just passing a function, and I think that's why it's very important to understand what's happening here, is we're actually just passing a function to be executed. So if you look at the other one, this isn't called here. This is called after execution. So when the map is called, it in turn calls those functions inside the, in this case, the filter function. Oh yeah, cool. Okay, so this is half value. This is half values. So yeah, this is that's probably bad naming on my half. But but yeah, because divide number. Oh Jesus, no, I broke it. Divide by 2. Here, this will make it a little bit more. Okay, does that make a little bit more sense when we put it out this way? Cool. Now let's run it and make sure it didn't break. Okay. So jumping in. So in functional programming, mapping is a term we use to transform an array into, well, I suppose we change each value in the array, but we return the same structure. Okay? So that when we call mapping, it doesn't matter this is a map function, but the idea of mapping in functional programming is always that we transform the array but return the same structure. So when we're talking about like iterating over objects, iterating over arrays, you would expect to bring back the exact same structure just with slightly modified results. So in this case, we're saying the numbers 2, 4, 8, and 10. And if you're a little bit better at maths than me, you'll probably be able to figure out what divide by 2 does. I'm hoping that the half values is correct. 1, 2, 4, and 5. We have a data scientist in the back, so we'll ask him 7. Okay, cool. Okay, so that's all map is doing for here. We're taking an array. One of the nice things to know about map is it returns a new array. We're not altering the original array at all. It's a new array that's given back to us. So it's never modified in the process. And we get an array back with a copy of the original things modified. Okay. So when we're talking about filtering, I think there is a great talk by Kyle Simpson. If you're ever actually looking for like really understand these concepts, that Kyle Simpson, probably all of his books are excellent. They're on GitHub. You don't know JavaScript. I think he's just rewrote them. So he has them all in one book that's smaller now. But basically, he puts this in a way, and I love his philosophy on this. Think of when you're talking about filtering, and so you know what way you should be filtering. Always think about filtering out something. So you're keeping what you want and getting rid of what you don't want. And that's just the concept. So we're filtering out stuff all the time. You can do it the other way, but I suppose best practice and what the word means is to filter out things and just make it more like English, I suppose. So if you're thinking about pasta, you'd filter out the water, you know? If you put it in a strainer, you filter out the water and you're left with pasta. You're left with what you want. So here, in the filter function, we're going to try and get even numbers by filtering out the numbers that are not even. Okay? If you're not familiar with the modulo, it's just going to show if there is a difference. If every time we divide by 2 and there's a difference, it will show you the difference between that number. So if it's 3 and you modulo 2, it will return 1. Okay? So it'll show you the difference between the values. So here, every time the difference is 0, we divide by 2 into 2, 4, 6, 8. They're all even numbers. The modulo operator will give back 0. So that's why it's easy to filter out the ones that don't. So it just expects a truthy statement. Okay. Anyone have any questions on filter? Cool. Okay, so now we are on to, I suppose, probably the main function. And I probably don't give it enough justice in this workshop, but just be known, once you go further down the rabbit hole in functional programming, reduce is probably the main function that you'll use to compose all of your functions, because it reduces things into a single value. So when we're talking about we have a long list of values, we have a long list of functions, we have a long list of anything really, and we're trying to get a single value at the end of it. Reduce is how we'd usually compose these things to actually get out a final result. So we would reduce it. And again, that's why when we think of reduce as a concept, not just as a function name, we're reducing multiple values into one. And we do that in map, if you think about it as well. So in the map function, we take an empty array and we take a single value and we make it into one thing. So it's still a reducing exercise. We're saying array, empty array, first element comes in, and we're joining those two together. Okay? We go to the second element in that array. We have an array with one element in it now, and then we take that element and we put it into the array. So then we're reducing it to, again, down to one element. So reduce usually is used to kind of get a singular result at the end, and that's why you'll see, unlike the other ones, it actually has an accumulator value, which is a value we can pass as the first value we passed. This can be a lot more complicated, and I have a function that I'll show you at the end that kind of takes advantage of this. But if we take a look at reduce up here, we'll say for summing numbers, we take the values and we want to sum them. Okay. Why I call this one what? Reduced values of all plus one. I think is that understandable by everyone? Yeah. Very declarative. Reduce values of all plus one. Okay. So we're taking the sum, which is every time the reduce goes around, basically what happens is this will be replaced by the last value passed in. So we go in, we start with 1. So the first time this is called, it comes in, the sum is 1. Okay? So that means the first time we go in, the sum is sum plus value, which is replaced by the first element here, which is 2. Okay? So the very first time around, the sum is 1 plus 2. Okay? So then the second time around, it ends up being 3, because we've gotten 3 from the last calculation, plus the second is now 6. Okay? Is everyone following? Yeah? And then we go around the last time and we get 4 plus 6 is 10. Okay? This is usually where people see these samples to understand them and go no further. Okay? But if you're going to become a die-hard functional programmer, reduce is the way we could compose lots of functions, lots of strings, lots of everything. This is how we actually take lots of things and output a single value, reduce it into a singular value. This can get very complicated. And that's why, even just as a sample, because I hate that just addition sample, we will take two functions and reduce them to be a single value, because I think that's a better sample. So the reduce value of an array add1 and add2, which are two functions, we will reduce them by using a run function on input, which is here, which takes an input and a function, and it returns the function with the given input. Okay? I don't want to jump into that too much. This is something you should play around with, because it's a little bit hard to understand when you're still grasping when these functions are being called. Okay? But what you're basically doing here is we're passing in add1. It gets passed through into the run function on input. Okay? And then each input that we get from there is passed in through as well. And as you see right here, we can follow this through again. So when we go first, we go 0 is the initial value on the input. Yeah? So 0 is the initial value. And then we get the first function, which is add1. Okay? So if we add 1 to 0, we get 1. Yeah? Everyone following? Okay, cool. So then 1 is the value next time. So input is 1. And the next function to be called is add2. Okay? And then down here we go 2 plus 1. So we get the reduced value of 3. Okay? Yeah, we get one thing. This is the way you should be using this. Get a singular value. We want to reduce it into one value at the end. So again, that's why it's called reduce. Reduce is to make things smaller. And to reduce it into the smallest part is 1. And most people can get their heads around map and filter very easily because it's just a bit of functionality. It's that initializer. You can get your head around that initializer. You can do so many different things. You know, you could call a function which could be the actual initialized value for this. So I could say, I could put in a function that returns 3, okay? But then I'd have to call it straight away as well. Because again, it could, yeah. So the technique then, well, like I said, let's change this to 3 here and run it. Oof, that is just the extra RAM. So see that? We have the initial value of 3. We add 1. We add 2. Okay? That's when this becomes powerful. This is when this becomes a really powerful concept. So suddenly we have 2 very separate functions, but now they're playing together. So we don't need to make an add 3 function. We can use the functionality we have to build up the more complex functionality. Obviously, this is add 1 and add 2, so it's not that complicated. But you can start seeing, like, if we had an actual array of different things. So think if you had an array of, say, get username, get first name, proper case stat name, you know, in the reduce. So you could actually then pull out a clean string that looks like what you wanted. And then you could even have append to DOM as the last part of that, you know, like, or create tag. So we're creating a HTML element that we'd be ready to put into DOM. So then all of a sudden, it's now taking it out of the land of make-believe, where we're never going to actually write an add 1, add 2 function. We're going to actually create an element that we can append to the page. Yeah, let me go through it one more time, okay? So in reduce, we have initialized value, which is the first input each time, okay? So every time we go through it, think of this number as changing, okay? So if we walk through it again, okay, we're going to put this back to 0, okay? So the very first time around, we run 0 goes into run function on input, okay? So run function on input takes an input, which is the 0 in this case, okay? So this is 0, and then the function is actually the first value, and that's why I was saying you need an initial value, because it has to have 2 things to play with. It can't just use 1. Okay, so whereas the other methods that we were looking at, we could have filter and map, we just had 1 thing that we were looking at. Reduce requires 2 things becoming 1. Again, like map does for you, we're taking an array and an element and we're reducing to 1. This takes everything and reduces it down properly to just 1 item in the end you're using. Does that make more sense? You can. There is, you can get complicated. There's a lot of fancy things you can do with this. So the reduce has, like, once you get into this, so that's I suppose the function itself can take more than just the value. You can actually take the count and where it is in the value and everything. There's a few more parameters. So if you want to, like, dive into what can be passed into these functions and things, look at Mozilla or MDN. But, like, I think for the simplest case, just remember you need an initializer, okay? And then you work with a function. No. So here is 0, and here is actually the first function. So then the next time around, it's summed up the value of 0 and add 1 to 1. So now the first value is 1, and add 2 is placed here. Does that make sense? And so then we get to 3. So that's what it means to reduce something. So we're reducing it to its smallest possible form, which is usually a single value. Any questions? Cool. Just to make sure I kind of summarize this, is these 3 functions aren't the only, I suppose, functions that JavaScript gives us to do functional programming. Functions like for each flat map, reduce write are other samples of functional functions or methods that we get. So it's definitely worth knowing these things. Then all you have to remember is to iterate over each element of the array. Okay, or that actually doesn't have to be an array. So when in functional programming, we have a thing called functors. Does anyone know what a functor is? Is that a wild scientific concept for anyone? Okay. Sorry? No, a functor is actually anything we can iterate over. Okay? So in functional programming, you'll notice we talk about iterating over all the time, but we can iterate over objects. We can iterate over the keys in an object. We can iterate over a map, a map structure in JavaScript. We can iterate over an array. So a functor is an iterable. So it's something we can iterate over. Functor, this is my bad one. Functor, Functor. So we run a function on each element then basically in functional programming. Okay, so we're trying to just run the function. Again, this is why I told you the exercise of pulling these functions out from anonymous functions takes away this scary function, because this is functionality people just don't realize is there because they're used to a pattern. I'd say stop looking at the patterns and look at what's happening. These are very basic concepts when you understand them, but even the most senior of engineers fail at interviews when they're asked in detail about these concepts. So don't worry about, like, if you don't understand them and you feel like, oh, I'll never get this. Trust me, I'm still learning this stuff. Like, it's not like I just suddenly clicked. I have notes here in case I get lost for words, because this is a complicated subject. Okay? So the next big concept that we're going to touch on is pure functions and immutability. Does anyone know what a pure function is? No side effect. Perfect. Yeah. Or that, you can give it an input. Given the same input, you'll always have the same output. Is the pure function side of things. And then the immutability would be actually the no side effect. So that's why they're usually seen together. That's why I branched them together. Because usually when you hear people talk about pure functions, they kind of guess that you're talking about the immutability side of things as well. But I'd rather just be really explicit in case you're asked in a separate context, what is immutability? So, pure functions. Given the same input, we'll always return the same output. And we're trying to produce no side effect. Okay? Immutability is when something is immutable, it cannot be modified after it is created. Okay? So we usually combine these two together because we treat things like they're immutable when we're trying to use pure functions. That makes sense? So actually, what we're going to do is we're going to go into the code again. And we're going to go into the pure function side of things. And you can see the exercise here is to make this pure. Okay? I'm going to give you a few minutes for those who understand this and what I mean by pure. And then I'm going to actually talk through why this isn't pure. And then it will hopefully make sense to everyone. But I also want to give people a chance to try and figure out, based on what I said, no side effects. So when we say side effects, I suppose what we're talking about is something in the global state changing. Okay, so something changing. So if I ran add 2 twice here, what would I get? Will I get the same value every time? If I give add 2 and x, if I say add 2 and 2 again, will I get the same value? So, sorry, I made a mistake there. And what we're doing is we're saying num plus equals x. So we're saying the value we add to num and returning num. Okay? So that makes more sense. I definitely didn't have enough coffee today. Okay. So here is where we see side effect. Okay? In this code, we have add 2 called 3 times, and all of a sudden we'd expect with this last one, we'd expect to get a 7, yeah? So let's call this inside the console log to see what we get actually this time. Yeah. 19. That was unexpected, wasn't it? Yeah. That's the concept I'm trying to drill home here, is where this is not a pure function. So what you would be expecting here when you call this function add2 is that 5 plus 2 would be 7. But instead we get 19 because it's referring to a num outside of its scope. So what we're going to try and do is make this pure. And how do we make it pure is we would have to make sure that num got its own little place where it doesn't change every time. Okay? Or if you're really well, there's no, like I said, it shouldn't, in pure functions we shouldn't have references to outside variables. We should have all of the parameters we need to do the calculations inside the function or be passed to the function. So maybe we would pass num as a parameter here, because then num will update inside. Okay? But when it doesn't find num, when num isn't referenced, it'll update the global variable. Okay, so I'll give you another couple of minutes to make this pure, and then we'll jump back in. So this is an example of it being pure because we don't need anything from the outside of this function. Okay, this would be a more functional way of doing it, because what we said is we want like one line size pieces of functionality. So this is a real functional pure function. I said, like, we know on line 16 is where this will break if it's broken. You know, it's very easy to debug now because it's one line of code. Okay? It might be difficult when you aren't used to that syntax, but when you get used to it, it means your errors are on a single line now. Okay? There is no outside reference, and we get the expected result in the end here. Okay? Because we didn't interfere with the num. Okay? That makes sense? So this is where we get into the piece that scares everyone. Okay? Which do you want? Do you want the complicated answer first? Yeah? No, I won't give you the complicated answer. There's no question, I suppose. This is closures. We're going over closures in the sense of understanding what a closure is in JavaScript and how to create them. Okay? So there is the scientific way where we can talk about lexical scope and the way JavaScript does things, or we can talk about how JavaScript, how its scoping mechanism lets us remember variables that are declared. Okay, this is just when you return a function from a function, you create a closure. Okay, when you return a function from a function, you create a closure. Okay. So this is something we've been trying to avoid. So this is kind of counterintuitive in a sense of, what if we could add memory into our function? Okay? We've been trying to avoid that. We've been trying, like, literally all of this has been like immutable. So truly functional code, people wouldn't be using closures, and we'll touch off that. But closures are a way of making predictable state. You know, we enclose behavior. Okay? So that'll make more sense in a second. Okay, so what if we could give our functions some memory? Like, imagine we could a value like num. We had a num. We wanted to count something. Every time we call a function, maybe we only want a function to be called once. Okay, and we only want that function to ever be allowed to be called once, or else, you know, like, we just can't do it again. So that's probably a useful time for that. Consequences are contained within these small functions. Okay, so this is the other kind of paradigm of closures. When I said a function that returns a function, that means the consequences of the inner function are contained in the parent. That makes sense? Okay, so the scope, instead of going into the global scope to look for something, it looks into its parent scope. Okay? In JavaScript land, and this is actually something cool to show you as well. Okay. When we create a closure, what JavaScript is smart enough to actually go and look for its dependencies at the time of creation. Okay. So when it returns this function, it realizes it doesn't have num. Okay. So it creates a reference to num. But blah is not used anywhere. Okay. So that's actually garbage collected normally by the language. Okay. So that makes it very memory efficient. So we could have 100 different statements in there. We're not making a copy of the whole function. We're not making a copy of anything. We're making some references to the things we need at that time. Okay? So here's the next fun part of this is, what if we redeclared this? We'll call this the sequel. Okay? What's going to happen when I call console log the sequel here? What is going to be the value if I add 2 to this now? You confident about that? Let's have a look. 2. Ah, okay. All of a sudden, we can start to see why this concept is a powerful concept, okay? Because let's step through this line by line, okay? So you really understand this. And I haven't even got into the sample of actually adding memory, yeah? Okay, so when I call add to with closure, we call new function. New function is this, okay? This returns a function, okay? Then I need to call the inner function, which is this, okay? So to call that, that's why I had to refer it to something else. And that's why now I actually have to call it with a value. So the value is x here, okay? So 2, and it goes num plus equals x, okay? So I can actually change this if this makes more sense than just up it a little bit. So you know it's not the same thing being run over and over. So the first time I go around, we say add to a closure. We say num is equal to 0. We have a reference to num in its little, so I suppose it's a little place of memory that it remembers for this instance. And we say num plus equals x, which is 2, which is going to be 2, which is what we see here. Okay, let's run this again with the new values. 3 plus 2. And 5 plus 5. Okay, so like you can see actually we've added all these all the way up. It's actually remembering the num here each time. It's being modified, it's being mutated. And that's why I said you'll see this as a functional concept in JavaScript, but those diehard functional programmers will probably tell you that you shouldn't be using closures because it's impure. Okay? But this is a way of kind of managing our state and managing or controlling the error, because at least we know where it's going to be effective now. It's only going to be anything that's inside this scope. Okay? So that's a pretty difficult concept to get your head around. Okay? And that's why I'm going to kind of go into another sample of this. So this is where we talk about kind of outers and inners. So I'm going to give everyone a few minutes to kind of examine this example of a closure. Okay? I think it's very similar to the last one, but I just want to see if people can get their heads around why it's doing what it's doing. So the one thing to be very comfortable about this is probably the most misunderstood concept in JavaScript. This is probably the most difficult thing to get people find to get their heads around. And it's probably the most asked concept in JavaScript interviews is, what is a closure? When we call outer, let's go line by line here, what happens? Okay? We declare a variable called count, and we assign our value to 0. Okay? And then we have a const add number to count, which we're assigning a function. The function doesn't really matter now. Let's just say it's a function, okay? So add number to count here is a function. And then we're returning that function. So when we call outer, add number to count with closure actually gets returned add number to count. Okay? Does that make sense so far? Yeah? Now I mean this, like the most veteran, the most senior engineers still don't get this concept, so it's okay if you feel confused. You might need to go over this a few times. Okay, so when we declare this, what happens inside this, okay, is it looks inside, and when we call this, it will actually be smart enough to look for any dependencies. Okay, and a dependency that we don't have inside add number to count is actually count. It's not inside that, so we have to look outside it. Okay, so what JavaScript does in this instance, it's called a variable environment, a VE, and that's part of lexical scoping. Now, if you want to read up on the science behind this, that's the term you're going to look up. It's lexical scoping, but that's what the static scoping that JavaScript has. It lets us create a reference, or it will find the missing piece. It'll infer it. So if there's anything else, it just garbage collects everything we don't need and remembers what we do. Okay? Okay. So it remembers the scope here. Okay? If we declare count here, this is where this gets really counterintuitive to what we have learned. Okay? This is where the closures get a little bit complicated, if they weren't already. Okay? Okay, so what we're used to doing, if we realize this, okay, so what we're used to doing is when we don't see something, we go outside of its scope, look for it, yes? So a lot of people would guess then, when we say here, which is a reference to this, that it will look in the global scope count, okay? But as I said, because of lexical scoping and the variable environment, we actually get a reference to its inner scope. It looks to where it was declared, okay? So it doesn't look outside into global scope, it actually looks inside to where it was declared, okay? And that's where the closure concept is. A really powerful concept if you can understand it, but basically it will remember where it was created rather than where you're calling it. Does that make more sense? So if I call this again, we get the same results, okay? It doesn't go outside, it doesn't look into the global scope, which you'd expect because it doesn't have the parameter. It goes to where it was created. And the same then, we can create a new instance, which we can then basically, we'll go with SQL again, okay? And when we do this, it runs outer all over again, okay? And when we run outer again, what's the first line? Let count equals 0, okay? So that's when it's defined. And when we define it, let count goes back to 0 because it's just running that function. Now it's not so crazy. That's how it got back to 0 when you made a new instance. Is because you actually called it again. That makes sense? Are people a little less confused now? No? Still confused? Yeah, okay. Well, you want to see the function? Oh, you want to see like, okay. Oh, you want to see the SQL. You want to see the SQL in action. Okay. So let's declare them first. And one. Okay. This is just for entertainment, I suppose, because Colin wants to see what happens, because he can't figure it out mentally at 8 o'clock in the evening. Does anyone guess what's going to happen here? They're totally separate. That's okay, you see? 1 plus 1 is 2. I'll let the data scientist in the back confirm. That's correct. Okay, we've got the maths right. So 1 plus 1 is 2. Yeah. Yeah. So that's what I'm saying is the scope. The only time count is 0. Let's get rid of this so it doesn't confuse things. The only time count is 0 is when we declare outer. Okay? And then it remembers count from there. And that's what a closure is. It's a variable environment. It's where it remembers variables based on where it was defined. Okay? That's pretty JavaScript specific. That's one of the most powerful features of JavaScript. And it's also one of the most confusing features of JavaScript. Now we can see the consequences are contained. So that's what we want as well. We want to contain these things in functional programming to the smallest window of error. So, function declaration. Can we add functionality to predefined functions? What happens if we've created a function? Okay, say we have add2. Okay? We have a function called add2, which just adds 2 to an input. How would we make that, or like change that? Could we do it? Is it possible? Okay, change it, not override it. How could we, without breaking it, without deleting it, okay? How could we add functionality? That's where this concept of function decoration comes in, where we put some lights and tinsel on it, we decorate it to make it into the pretty thing we want it to be. Okay, so let's jump back into the REPL again. Okay, so this is kind of the last proper concept we'll go over, but it's very important again. As I'd probably say any concept, I could have another 10 concepts, and I'd say that's the most important concept. So function decoration. Okay, so here you go with, and I touched off it earlier, maybe we want a particular function to run once. Okay? When you have a function, we don't really have control over how many times a function is called. Okay? We need that to be very, very opinionated. How many times we want a function to be called. Okay? So I would say take a couple of minutes, just kind of mentally parse this, and we'll walk through it then. Okay? We'll step through it. But this is basically combining the closure that we've just learned with a pattern called function decoration. And that's how we kind of can add, using a closure, we can actually create memory, which can create, I suppose, a decoration pattern that lets us to do things that our functions wouldn't normally be able to do. So yeah, just take a minute, try mentally parse it. I appreciate it's late, so most people's brains are turned off probably by now. All right. Does anyone need more time to look at this? Or are you just dying to go home? Okay. So if I showed you this without telling you what the name of it was, you would probably have said it was something like a closure. Yeah? Looks very like a closure. We're creating an outer reference inside a function. So it looks very like a closure. And actually, just as a caveat, a lot of people, you might get, some people will call just the variables that can be accessed the closure. But I think that's misleading because the whole principle is a closure. But like you'll get some people, so don't get tripped up if somebody says the closure value, because sometimes these variables can be called closure. So yeah, I just don't think that's a very intuitive name when we're talking about the concept as a whole. Okay, so in the constant run once, we're going to take something that says convert me. I wonder what that will be. So that will be our function we want to decorate. Okay. We create a counter and we set it to 0. That's going to be our closure here. See how this is starting to tie together? And then inside we create an inner, which is function. So const inner, which is equal to a function. Okay. And we return that inner function. Inside inner, we create an output, which is convert me and an input. Okay, so this is where it gets a little bit confusing. So let's follow convert me. Where is it labeled? Okay, convert me is the function we're going to pass to it, and it becomes output. It is executed with an input. Okay, or is called with an input, and then we return it. Okay, so if we have a function like add2, because that's as complicated as I'm going to get tonight, and we want to make sure this is a function that can only run once in our code. Okay, now this is a really useful method. Maybe you can think of ways around this where you might want to disable a button. You might want to do something or allow a feature like you can only send an email once on the page. You know, you don't want to allow spamming. So this would be a really simple way to just turn it off, wouldn't it? If we could just let the function be called once. Yeah, that's practical. So run once add2 equals run once, and we pass it add2. Okay, so we're combining functionality here. Okay, when we call run once add2, we are saying run once add2 is referenced here. It's passed in. We initialize a counter to 0, and we say the inner is the input, whichever. We don't have a reference to that yet. Okay, because we're declaring a new function here. Okay, so want me to stop? It's not being used yet because we're returning another function here. That's why it's a function decoration. We're decorating a function to be used later. Okay, so that's why we are putting a function and returning a function. We're never actually calling that function. Okay, so in the inner function, we create the output, which is the convert me with the input, and then we add the counter. Okay, so there is our closure value here, 0, when we call run once. Okay, so we haven't called the inner function yet, and that's what we were going over before in the closures, that you still have to call the function outside of it. And that's why when we come down here and we say run once add2, we can add 2. Oh, my maths is terrible. It's definitely not 20. All right, so we try to run it twice there. So if I console the log, I just want to see both outputs. So we'll run once. We'll add 2 to 2, which is 4, not 20, as I had commented before. And then we'll try to run it again. And because of our closure, we actually remember and we can check and say, hey, you've been run already. And we can stop it right there. And then we fall through to our return statement here, which is sorry. Could be a Canadian function. All right? That makes sense? That pattern is known as function declaration. And it's a really useful pattern as well, because instead of recreating a new function to do that little bit of extra behavior or making a bigger function with the copy-paste functionality of before, you now have the inside of this could be just tested once. The convert me function could be tested once. And that's what's so powerful by this. So we separate the concerns. We can test these independently of each other. It's very easy to test these things. Very easy to debug. We know where it's broken, because it becomes definitely down to a use case. All right. And again, because of time constraints, definitely because I just didn't learn enough for this workshop. All right. We won't look at all of the concept. All right. There is one major concept that I didn't get into, and it's something that I definitely dive into afterwards, and it kind of builds on top of the reduce functionality. And if I had another half hour, we'd be probably going into that more than anything. And that comes down to partial application and currying. Okay? So currying is calling a function after you return it straight away. Okay? Yeah, sounds confusing if you haven't seen it. And so what I want to do, I'm going to go through kind of a sample of a partial application just to have a look at the code. We're not going to dive into it because I don't have time, but I want to point out the code so you can look into it afterwards. I'm probably going to upload a video shortly on the actual partial application and currying in the next week or so anyway. So you can look in for that. But where the code is there is we have the partial application code here, which is basically what we're trying to do is we're trying to normalize our data. So a lot of functions. So if you think of, we have a list of functions and we wanted to like call them in an array in a reduce. And we want to normalize the inputs. Say some functions take 2 inputs, some functions take 1 input. And we don't really want to, write all of our functions with 1 input. By using something like partial application, we could actually normalize the data so that we can use the same functions that have different inputs and get an output that's expected without something breaking. Because as you can imagine, if you had kind of reduced over something that only had expected a function with 1 parameter, it would be very brittle. As soon as you put in a function with 2 parameters, it'll be missing a parameter and it will blow up. Okay, so that's why you're really going to want to look into the kind of partial application and currying, and that's automatically calling the functions as well. So I just want to point that out. All right, and then I guess the main thing is thanks for coming and listening to me. I'm guessing the pizza and beer helped. It was probably better than the conversation. But also, I suppose, does anyone have any questions on what we covered? If anyone needs to run now, you can fire ahead. I won't think you're super rude. But yeah, if anyone has any questions, now's your chance. They have, it's not, some languages, it's the only way to do it. Like Haskell, functional programming is the only way. And I suppose then you have other languages like Java and Python that are a little bit more flexible, which give you kind of object-oriented programming, functional programming. And then that's an easy way to actually you just decide which pattern suits you better. Yeah. Excellent. Ever? Great, cool. If anyone wants to add me on LinkedIn or any of those other things. Oh, the nearby. Yeah, I'll put that up. So what I always do as well, which is always very useful, is I'm going to start a post in the meetup. So if everyone wants to throw in their LinkedIns and everything else, because I understand we're nerds and we don't like to talk to each other in person. So I'm going to break that ice, and I'll just let you put links to your LinkedIn so you can pretend we're friends now. So that's way easier. Okay? So I'll start a post after this, and you can connect with each other, because as I said, this is something I always harp on. Networking is super important in the industry because it's the easiest way to get a job or your next job. All right? All right, brilliant. Thanks.